Okay, so went over some conceptual stuff about functions, but it's an active subject. So let's look at this in an example. And I did not open up the class example and do any preparing for this. Normally, I try to prepare really well for classes, but periodically, I do like to throw in things that are not prepared. Because, well, when I do all this and practice the examples beforehand and all that, y'all have probably noticed that's not very reflective of what it's like when you put code together, right? Typos happen. Sometimes algorithms don't work out. We have to make adjustments, and then more typos happen because typos happen all the time, constantly. And it takes lots of little adjustments. And we don't have time in the classroom for that, right? We're kind of restricted here. It's a long class, but there is some of that needs to be dedicated to lab time so that we can practice it. But when you're writing your code, probably there's a lot more back and forth than we see in class examples. So I do like to periodically come in and do unprepared things so that y'all can see it. It's the same way for me. There's typos and adjustments and all that stuff happens. It's just I practice the stuff beforehand so that we don't waste our class time with typos. So yeah, this next section I made it a point to not prepare for, and every time it started popping in my mind about thinking ahead on it, I tried to push those thoughts out of my mind. I didn't even want to think ahead and have like more of the actual process work. I like to work that in occasionally so y'all can see that it is probably what it's like when y'all are putting your code together, and not those examples that just seem to flow together so nicely, because I do practice those beforehand to not waste time in classroom. So I'm gonna go ahead and share my screen. Let's see, is XAMPP running? Looks like I do not have the server running, so I'll go ahead and start that. I have it pinned to the taskbar, but if you want to start your localhost server, it might be in the start menu, or if you're using a domain host somewhere or those Amazon servers, as long as it's up and running, because we have to have a server to do PHP. Okay, I see some green there, so XAMPP's running. I'll open up the files. Whoops. And the first thing I want to do is throw an error that probably should have thought to throw this error on day one, because it's kind of a vague one. And but it shows up a lot. Whoops, not that one. This example. I guess this is the most recent version, so I'm going to make a copy of that and rename that something so I can find it again. Rename module 3 blue. I'll put -A this time. This is the first one about functions. So I'm going here and I'm just going to select everything and open it with Notepad++. I'll probably close a few of them. Oh, I'm looking at the CSS, and that just reminds me, there was a change I wanted to make in the CSS. You might remember the stuff we were looking at fit fine, but the nav bar going down the side, well, I'm going to open this up and point at the screen for this style sheet instead of just hoping everybody remembers what we were looking at last week. So navigate to localhost and the My Pages folder. And I still haven't put an index here, but got that generic one. Class. And here's the new one. So this part was set for 15% of the screen. And in the original style sheet, I just left this to fill in. But some of the error messages were really long, and then they only showed up way down at the bottom. Like it decided to avoid word line wrapping. So it tried to stretch them out the whole way, which means they didn't fit in that 85% that remained on the screen. So it just decided, okay, there's not room, and put it down below it. So first thing I'm going to do is in the style sheet adjust that. So if that's taking up 15% of the screen, I'm going to set this with, there's still 85%. And then there was, if you remember, one of the updates on the styling, I put an article, put something in between there. So I'm going to say no more than 75% of the screen. That way there's still plenty of white space room and stuff. And hopefully then it'll activate the word wrapping instead of pushing everything down below. Could probably do a little bit more math to be more exact, but I'm just going to restrict the width on this section. That way it won't put things way down at the bottom where we have to scroll to see them. It actually happens on somebody's homework. Several people just modified that style sheet for their homework, and I can't remember whose it was, but somebody's, it was on my desk. It was fine on my big monitor, but it wasn't working on my small monitor because I have two different size monitors on my desk. So on my big monitor, it looked right, but if it was on my small monitor, all of their form and stuff was way down at the bottom and had to scroll down to see it. So yeah, just adding that in the style sheet. Don't think I need the style sheet again. Don't need the SVG. Don't need the text file. And yeah, that extra credit thing with the string parsing is to take this string that's in the text, that's stored in the text file, and just parse through that to pull out bad reviews, basically. Well, maybe not bad reviews, the nonsense reviews, things that aren't really reviews. The stuff where like bots found there was a review page, so they put a link to some site that an advertiser paid them to link to. You've probably seen lots and lots of those on review pages and comments and things like that. So the reviews page, we're okay with. That one's okay. Oh, wait, there might be stuff to clean up. I will keep those open. So that and that, we're going to look and see if there's stuff to clean up. So I'll keep those open. We're doing refactoring, so these ones that are only HTML, at this moment, we don't have any refactoring to do. But remember, that term refers to cleaning up your code. So things like making sure all your indents are consistent and there's white space to make it nice and readable. The idea is, imagine if somebody else is going to maintain and then later update your code. You're just writing the initial version and somebody else is going to take care of it, keep it running, and do version 2 of it. Be as nice as you can to them. That's the idea of refactoring. Just make it cleaning up the code. It's not necessarily debugging. It's just organizing it, cleaning it up. So the HTML, could be some refactoring, being consistent with white space and indents and things like that. But we're looking at functions today. So I'm going to close those HTML pages. So the refactoring has got to happen in one of these. But before we do that, I want to throw this common error because we should have seen that already. So I'm going to go to the confirm page and I'll just do this. I think it'll throw it. So I'll save this. Did everybody see what I did there? On line 60, I deleted a curly brace, a closing curly brace. Because the closing ones are more likely to get forgotten than the opening ones, but we would see the same message.
Yeah, I think I've probably done this a few times.
Yeah, so now if we go to the order page and try to hit order, we get this. Unexpected end of file. So that's the error. It hit the end of the file when it didn't expect to hit the end of the file. It tells us the problem's on line 85. And most of our errors, it would give us a line number, say like unrecognized variable or undefined variable on line 34. So we go to line 34 and fix that. So it says it's on line 85. We come over to our code. Line 85 is a closing HTML tag. That is what we would expect at the end of the file, right? So that line number thing doesn't help us. So whenever you see syntax error, unexpected end of file, that means you're missing the curly brace. That's your curly brace error. There's an opening or closing curly brace that got off there somewhere. And to fix that, you just, start at either the beginning or end, and most text editors will highlight them. So if you put your cursor beside like this opening curly brace, it shows which one closes it. Or this closing curly brace, it shows that it goes with that opening one. And just go through and check all of them and look at that highlighting until you find one that doesn't close like it's supposed to. That one closes. And then that one, when I put my cursor beside it, it didn't highlight. So it doesn't have a partner. So whenever you see that error message, that means closing curly brace issue. So if I reload the file, resubmit the form, put that curly brace in, and it works like it should. Might as well take out an opening curly brace while we're at it. I'll take out this one. Reload the file. This one's a little more specific, right? But it's still, the line number's wrong. It hit a closing curly brace when it didn't expect to. There was never an opening curly brace. So if we look at line 57 is just a closing curly brace. So there should be a partner for that one. So we check the ones around it. That one's partnered up. The one before is partnered up. There's that one missing right there.
Okay. So if it hits on a line number that has a closing curly brace, you can probably guess that in whatever that if statement or function or whatever it is that curly brace closes, you're missing an opening curly brace in that little section.
Yes. And if it says unexpected end of file,
that's a closing.
A closing one.
And actually God knows where.
Yes. Yeah, that you just kind of have to check through. So I'll take another closing one out in the middle. And yeah, so this one was the middle. There was opening and closing curly braces after that, but it's back to that end of file. And closing curly braces tend to get missed a lot more than opening curly braces. But that's what those errors look like. It's a very common one, and kind of forgot to show it in class. I like to look at the error, see the errors in class, so that we know what to expect. So we know how to fix them instead of fixing them beforehand. So I like to actually see the errors. So we need to clean up this code, which means look for things that can be moved into functions. So this looks like it happens a couple times. Like Joe mentioned earlier, a just concatenation function that kind of cleans all this up might be nice. And you just want to dig through your code, look for places to clean it up. Sometimes it can help if your code is nicely organized, somewhat organized, like you're consistent with your indenting and white space and stuff, to make it readable. It can help to zoom out, like zoom way out. Zoom out. Do I have to keep hitting that button? Oh, there's one. I'll zoom way out to where we can't even read it, but we can kind of see some little patterns showing up, right? like, looks like we have a block there. Or this block.
Yeah, I would guess all those is sets or is
Yeah.
sets.
Yeah, and that can help sometimes for looking for things to clear up too, because just that geometric shape, it's like, okay, there's something very similar going on here. Oops, it didn't mark. Going on here and here, can see without even seeing the words, just the basic shape that those words form. That something something similar is going on there, or that part, it looks like a lot of similarities going on. So that can be a helpful trick for trying to figure out what to clean up and things like that.
Okay, the question is going to be, how do you pass the things from that post? Well, it's not really. Is it an array really, or it's kind of an array? As arguments.
Oh, so that will our function. We're going to write our function elsewhere. I'll go ahead and create a new file. So here, over in this file, we are just defining functions. And then we are going to import it into this, so they will be tied together. These files will know about each other. That make sense? So what we
yeah, I'm just looking at the syntax, because basically the only difference is
grip.
Is what you're passing inside as the name or as the index for that for that post array.
What I was thinking is pass in that word, just that word. So post will be rewritten in that function over there.
Right.
And then just pass in the words metal or grip.
I'm passing in the associative index for the post array.
Yep, that's what I was thinking. So we can go set that one up first.
That would be helpful.
So we have our keyword function. Oh, let me start this off because it's PHP. So we do have to have the PHP tag still. This is just a library of functions that we're going to import, so we don't need any HTML here. I'll call it library. I think I may have misspelled that, but library.php. Yeah, I spelled it right. And then we'll just build up some functions here. So we have our keyword function, and I'll call this checkbox, just for lack of a better name. And we will need to pass some stuff in, right? Like we were just talking about. What's different in those is that index for the associative array. So we'll need to pass that in. I'll call it index over here. And then curly braces for what we want to happen when that function runs. And yeah, I'm just going to copy this because from earlier versions, I know that part worked. Paste it in here. And since I'm cleaning things up, I'll go ahead and fix the indenting. So highlight that. Everybody's used to tab goes over. If you weren't familiar with it, holding shift when you push tab goes the other way. So we're going to bring that back out and get it all lining up nicely. And now we need to generalize this because we're passing it in the index. So that's what we have to check here. And then we need to return things. We're going to return stuff and put it in that grip variable over back on the other side. So this is a return function, not a void function, because we need to get back some words in order to keep it operating the same way. So our keyword for that is return. And that one I just replaced was the word grip. But another time we might use this function, it's going to be a different word. So I'm going to put another parameter, and we'll pass in the words that we want back, as well as the index. And it gives us, we have to pass in all three parameters, right? That index, the true option, and the false option. I'll do something like that. The true op and false option. Unless there might, what would be some better words? Anybody have any ideas on words for those? Maybe check and clear. If the checkbox is checked, we have these words. If the checkbox is not checked, we have these words. And sometimes it takes a little bit of going back and forth to come up with the right word. If anybody can think of a better word for that, let me know. I'm gonna go with that. And sometimes, you know, you might write some other code and then later be like, oh, I got an idea. I know the perfect word for that. So refactoring is a cleaning up process so that, you know, and by the time you're finished, you want your code to be really clean and organized and well labeled and everything. So just trying to come up with some good words. Maybe I'll go back to what I originally had there. The true op and false option. Just after a moment, that seemed to be thinking. So if that is checked, then we're going to return the true option. But if it's not checked, return the false option. Does that make sense to everybody? So it's doing the same thing as our original code did. It's just the only part we kept is what was common for both of them. And then we replaced what wasn't common with generic parameters that we can fill in as we need to ask for this function, as we need that thing to happen, the checking if those inboxes are filled. So then we can call this over in our other script. So if we go back over to confirm script, I always like to put this right at the top. There's some stuff later that really needs to be the very first line. So I always go ahead and put a PHP tag right up at the top and do all the require or include and the session stuff really needs to be the top line. And some other things some things have to be at the very top. So I just go ahead and put all the general things up at the very top line. And then for this, we need to access that library. We need to tie this PHP script to that PHP script that has all our function wrote in it. And we can do it with the word require. Again, the server will just keep loading that into memory and run itself out of memory and then have to dump memory. So it's better to avoid that if we can. So I always use require once. That means load it in once and make a note somewhere that it is loaded into memory. That way the computer won't keep loading it in. And then the location of our PHP script that has all the functions. And to keep class example simple, like everything else, I was putting it in the same folder, but in almost every situation, such as your final project, you're probably going to want to have a couple folders to organize that. So Well, things to remember is if we need to go up a level, so if we're in one folder and we need to go up a level or two into over into another folder and then down a parallel branch of our folder hierarchy structure, .. / goes up a level. So you might need to put that a few times. But if it's just going down, I'll just write here. If we're just a couple layers down, other folder, we can just do slashes to go down. So we might need to go up and then back down into stuff. So hopefully everybody's seen that a couple times. Keep the class example simple. I'm just putting everything in the same folder. But organization goes a long way, and this is about refactoring. So thought I'd mention that organization in the folders as well. I usually have a folder called an index. The index page sits at the top level. Actually, do I have anything here in my pages? I'm very consistent about how I set things up. Okay, yeah, this is how mine are set up. There's usually one more here. This is a one-page thing. So the index page sits at the top level, and then I have a folder called pages, which has every other page, whether it's a .html page or a .php page. If there's HTML code in that file, it goes here. And if it's just PHP code, such as our library here, I'll put that in the folder called scripts. And then in resources, I'll have the JavaScript and style sheet. Usually one style sheet, there might be several JavaScript files. There's some other stuff there, but then I'll have folders like images or documents for PDFs. There's a PDF thing there. And I'm very consistent about how I organize things. That way, when I open my project, like I don't need those here because there's not anything to put in them. That way, when I open one of my projects, I know where everything in it is, just because of that consistency. Or if one of the things is missing, I know I don't have that in the particular project I'm looking at. But for class examples, that adds a layer of complexity that would take away from covering the syntax. So I just put everything in one folder here. But we can see it's already starting to lose some organization, right? There's intermingling of things, and we have to pause to look for a particular file, even with just a few in here. So folders can be very useful. But require once or include once, or it would be fine if you just want to use require and include and use the one-word ones. Whatever you feel like makes the most sense on your homework will be fine with me. But we have to bring that in. And there's some other stuff, like I said, there's some other stuff that has to be at the top. So I go ahead and put the imports up at the very top, just to organize it with that stuff. We could put that anywhere in there. So now these scripts are tied together. So we know about that function. So instead of doing this, come down here and comment all of this out and replace that with just a couple single lines. So looking at the previous code, so it looks like we're filling in that variable grip. So we're going to fill that in. And what do we call that function? I've talked a bunch since then. Call this function checkbox. And I was expecting a little bit of predictive things to pop up there, but it's not predicting. It might be because I have everything turned off. Yours might try to predict what goes in there at that point. And we can look at the one that just got commented out for what needs passed in. So the first thing is that index. And our arguments and parameters are just a comma-separated list. Where the parameters, we really need those to be a variable. But for our arguments, they might be literals. Like here, I'm just going to pass that one word in. I don't need to store it anywhere first. I'll just pass it in there. And then the return, if it's true, it'll return that word. I need that semicolon. If it's not true, return those words. So what was that? 1, 2, 3, 4, 5, 6 lines of code, cleaned up into just 1 line of code. So you can see it's going to make this script shorter, but it's really just and sometimes it's just moving it to that other script. That makes sense? And see how it's a nice copy and paste thing? If we get things working first and then clean it up into functions. It takes a little longer because we have to make multiple passes, but it becomes a copy and paste thing. The next one is that metal variable. Again, call the function checkbox, and then copy this stuff down in there. Sorry, the index we want to check on. If it's checked, we'll do this. Return this word. And if it's not checked, we'll return this word. The syntax there makes sense?
Mm-hmm.
So it should behave exactly the same. Let's go give that a test. And you always want to test as I save that. Yeah, everything's grayed out. Save button's grayed out, so everything's saved. You always want to test every chance you get, because if there's an error now, we know it has to be in those lines of code we just typed. Then reload, load in the order. I'll match the keyboard there, click a random color there. So that's fine. The checkbox is what we were checking. So I'll leave them both unchecked first and hit order. With unchecked, got no grips and plastic clip. I think that was the two that it was supposed to be, right? So now if I check the rubber grip, with grip and plastic clip, and I just want to check every combination, right? There's only 2 on this one, so I'll check them both checked. So we get with a rubber grip and a metal clip, or no grip and metal clip. So it looks like that worked out.
Looked like your price never changed no matter what you did.
Oh, I never changed the number. The price was on the radio buttons. If I go to click pins, those are more expensive. I probably should have put some prices in there, right? Rubber grips cost extra to make, and metal is usually more expensive than plastic. I guess it depends on the metal or the plastic.
Okay, so that's where the price changed. Okay, that's why. So the other stuff didn't work. Yeah.
Yeah, there probably should be prices there. It depends. The cheap nickel out aluminum alloys, those would be cheaper than nylon 6. Okay. So sometimes plastic is more than metal, but
okay, this is going to be a little confusing, because first we're going through doing our array. So we're going to do the arrays, but we're going to at first, to do the thing for Friday, we're going to forget that we know functions.
Yes.
And then after we turn that in, then we put the functions in.
Yes.
Okay.
Yeah, so kind of one step at a time.
I can't cheat and do them both at once. All right. Thank you.
If you suddenly realize that something would be significantly easier that way, just let me know. Make a comment there. But yeah, normally that's it's spread out. It was supposed to be spread out a week apart.
I have enough trouble getting one thing to work straight, let alone 2.
Yeah. So now that works, we can delete lines 41 through 56 have been completely replaced with just what lines, with 2 lines, which
and you have a reusable function.
Yeah, and that can be used over and over again anytime there's a checkbox. And I was expecting the predictive thing to pop up. I don't know why it didn't. Checkbox, normally a little prediction shows up there. But I might have turned that off with an extra setting or adjusting settings the other day. And anytime there's a checkbox, I can just use that function over and over and over again now. Pass in what to do if it's true and what to do if it's false. And there's no restriction there, right? That's a variable. So anything we put in a variable would be fine to pass in there, whatever that checkbox does. Maybe it's a color, maybe it's a integers, floating point numbers, pass in some math, whatever we want to pass in, we could use that over and over and over again because it is completely generalized. All this does is check the checkbox, and checked or unchecked, it returns something. So that's kind of like the goal of what you want to look for. You want to look for something that is as generalized as possible in order to reuse it over and over and over again. And clear out different lines. Sometimes there's just an organization thing, right? So all of this is very specific to this particular project, this particular file. So we could put that in a function. If you want to, you can set up the function to do that, pass things in. It's really just your choice on what you think would help to clean that up. We could put this over into a function. That way over here in our main file, the place where we go first, right? When we run this, let me go put an error message in here. I misspelled true op, misspell a parameter, and then run this confirm thing again to see what happens. Let's see what the error messages look like. So I hit order. Well, we can see that CSS thing fixed it. It doesn't run over now. It doesn't move everything way down to the bottom. Undefined variable, true op. So notice how it gave us the error message from the other file and everything. So our error messages still kind of look the same. It tells us what file it's in. It's not in the one we ran, it's in that other one that we included. So tracking down error messages, we don't have to worry about them not telling us which file it's in, but we could move things over to functions and just have a bunch of single line instructions here. So load this in. I guess cleaning up, we can probably take out that white space, then we have all the load in stuff. Then the price section, and then the string section. So we could move that over and just have a bunch of single line stuff here. I'll leave it here for now, but that might be another option. Copy and paste this into a function and return the total price. I guess I might as well do that. That would look a little cleaner here. Total equals, I need a function called find total. So go in a different order this time. The last one, we wrote the function first and then moved stuff over. Find total, and it looks like we need to know if it's either cap or a click. And those are an array, so we probably need to pass those in. So we'll pass in the style and then pass in that price array. Does that make sense? So thinking ahead, just calling the function, this is an array that has our prices. Prices array has all this, so we'll pass that in. The style tells us whether it's a cap or a click pin, so we'll just pass that in. And then this stuff, we should be able to just copy and paste over to that and make a function out of it. I'll hit copy, go over here, function, find total, it's a nice descriptive name. And then this needs two parameters. And I'm going to call them the same thing over here. Style and price. They both have useful names, so might as well keep those useful names because parameters will always have local scope. So it's not going to get confused on any scope issues or anything. Parameters are always local scope. And if I reuse those names, then I don't even have to, that's less that I have to change in the copy and paste stuff. I'll highlight that and hit Shift Tab a couple times, bring it back over to line it up. And we have that array, and the array brought in its indexes, so we don't need to change that. The style attribute is still either going to have cap or click, so we don't have to change that. Only thing we need to change is this is now a return, and we'll put it in the variable when we get on the other side. And this hasn't really shown up yet, but there's a bunch of curly braces there, right? And at the end, not many yet. We only have two, but you can probably already see just with two how it won't be long till we have enough closing curly braces to get lost in those. Right? If we needed that to happen repeatedly and wrap it in a loop, we'll have a third one there. So labeling our closing curly braces can be very, very useful. So I usually just do the major ones. So here at the end of the function. So I'll just add a single line comment after that closing curly brace and add in the label end find total. That way, don't quite get lost in so many of them. If you want to, you can throw in a bunch of labels and keep track of the closing curly braces because they can get a little messy. I usually just do the major ones, the end of, unless there gets to be a lot of them in there, but just a single line comment and a short comment can go a long way in keeping track of those. I'll do the same thing here in the checkbox method. And that way, as things get changed, we don't lose track of those curly braces. Because if we come through and make edits later, sometimes maybe this if else block gets deleted and replaced with a switch. So if that closing curly brace is labeled like it, and you can tell exactly what it is, you don't end up with extra or missing curly braces in the long run after editing. So that can be a really good idea, is to label those so you don't lose track of them. The top ones, those are usually right next to our keywords, so those don't necessarily need a label, but if you want to, you can put one in there. So I'll save that. And back over here, I'll test it before I delete that. So Never delete code immediately. Always comment it out, see if the change works, and then get rid of it. So I can see on the screen, this stuff up here has already been tested, so I can get rid of those. And so now we should still have the same total, which would be an easy thing to check. Or back. So 3 click pins should be $6. Oh. Line 19. Oh, looks like we forgot to pass something in. We need to know what the quantity is as well. So I'll just set up a parameter for that. And then pass it in over here. And it has the same name, which is not a requirement, but if we have useful names everywhere, it is something that's going to show up quite a bit. So forgot that other parameter, so we got to know how many there are in order to find the price. When I reload it, it should be $6. Yep, still found it to be $6. If I go back and try the other one, so 3 times $1.60 would be $1.80 plus 3, so $4.80. Yeah, so it looks like that still works correctly. Still works exactly like it did. It's just more organized. And I guess that one's kind of reusable as well, right? Because we're passing in something. It's looking for caps, so that's not quite as reusable. If we had generic names in that array, we could probably check it, but what would it take? Yeah, I guess we would need one more parameter to completely generalize that. Maybe a couple more. So that one is specific to this case. It could be generalized as just finding a price times quantity math, but we'd still need to pass in what we're checking and those conditions. So this one, that one probably stay specific. But then we can take all this out. You can see how the code gets a lot shorter. Our main script is getting shorter. This post thing, right? We type that all the time, over and over and over again. Every single one of our things has to have that. So everything I use here is just one word long. So you can't really tell, but I tend to type in camel case most often. When I'm doing my first draft of stuff, camel case is what's going to come out. So sometimes for the classroom setting here, I'm going to leave it as post, but I have redone that or session stuff or request, just redid that word as something in camel case. So like a function called post. And it takes in an index. And all it's going to do is return $_post of that index, which is essentially the same, except now when I ask for stuff from the post array, it matches my normal syntax, the normal syntax I tend to write in. So that can be a useful one. Then the code just matches what you normally do. And I'll label that closing curly brace in post. Keep track of that. And We don't have to put white space between them. If I take that white space out, I always feel like it looks a little bit cluttered without white space between our functions. So I like to leave a little bit of white space between them. That way we can quickly find them. That's an important thing with refactoring, is being able to see everything and get to all of it easily. So just a little bit of white space between functions goes a long way, I think. But it's up to you. Whatever you think would work. And see how it just can keep making this shorter and shorter and shorter. And even if we're doing the same thing, we can do it all in functions. It makes it a lot easier. And like Joe pointed out earlier, if those, I just use the default passed by value. So if we want that data to be different when we get back, just remember put an ampersand in there. And that means passed by reference. So that way, after you run the function and then get back to the main thing that called it, in the case here, over the on the confirm script, the data that you sent in will actually have been changed as well. Which will probably be an important one for this part. So we're just constantly changing that confirm string. But y'all can mess around with that in lab time and see if you can get it working. The idea is just kind of look through the code and look for spots that can be cleaned up. Things that happen more than once, the reusability issue. Put those into a function, and then it turns it into a single line to ask for that function. Or just to organize things, even if it's not going to be reusable, it helps to make it much more organized. Because now if there's any sort of problem with the total price, we know exactly where to go. The total price has to be on those lines in the library. So much more organized. If you wanted to, you could even do things like throw it in alphabetical order so that as the library gets big, it's easier to find those, or some sort of categorical order. Some way to organize how your functions are in that script. Because after you write them, then it's just copy and paste, right? Then just you can take that, cut it from there, paste it in up there, and reorganize this and make the library nicely organized too to help find things. So I'll look at some of the other scripts on reviews.php. So we could put that in a function. What do y'all think? Should we put that one in a function or not? It's only 3 short lines. So I think I'll skip doing that, but that is something we would do a lot, right? Create a handler, then we could just pass in the name here. And we could have like a read function that does this same 3 lines every time. Then all we have to do is pass in the name of the file we want to read. And a write function that, again, is only 3 lines, but just pass in the file we want to write to, and in that case, what we're going to write. I think I'll leave that like it is because it's not necessarily long or anything. A little bit of cleanup that could happen there. This one we could do as a function, but they wouldn't really be reusable, right? Nothing necessarily that would get done over and over and over again. So I think that's probably most of the cleanup I see in the example, just a couple things there. We could move that stuff over. But does the syntax on that make sense? Keyword function, the name of the function so we can ask for it, and any parameters. We don't necessarily have to send in parameters. And we don't necessarily have to return. We can just come over to the function and do a bunch of stuff and then come back. Like have the echo statements here so that after it finds the result, it prints them back to the web page for us. And then just go back to the next line of code in the calling script. Anybody have any questions about that? And that's what you'll do for the homework. Just go through your code and look for places where you can clean it up and make it look a little bit better, and organize it into a library. Find reusable things or some maybe things that kind of look like a mess in that main script and move them over to a function and refactor it. Make it all look nice. So if there's no questions about functions, that basic idea on it, I think we do have a couple minutes to quickly cover recursion. I'm going to erase the board here. This stuff's been up here since before the break, so hopefully it made it in everybody's notes. You were taking notes and following along. I was hoping we would find time to talk about strings today as well, but it looks like that's going to get pushed back to Monday, because this next thing will only take about 15, 20 minutes. And then it would leave a good bit of lab time to start cleaning up your code. I just want to quickly go over the process for recursion and kind of look at an easy case. One of our problems that's already set up for recursion. So on machines, well, when we need things to happen repeatedly, in most of our languages, we have loops. We've seen that over and over again. We can just set up a while loop or a do while loop or a for loop or for each loop, and something that's going to keep repeating and do things over and over again, usually based off conditions like we have in selection structures, which make them somewhat easy to, make them fairly easy to work with in most cases. But that's something in the programming language. That is not something about machines. What machines have is feedback. And some of our programming languages do not have loops, so we only have recursion to work with. Machines only natural way to reiterate is feedback. Feedback is what is natural to a machine. And well, as Americans in the modern world, I feel that it's safe to assume everybody in here has experienced audio feedback, right? Somebody sings into a microphone, that signal goes down, gets amplified, and comes out louder. But then that louder signal, if things are positioned in certain ways, that louder signal goes right back in the microphone, goes down the line, gets amplified, comes out louder, and that even louder signal goes back in the microphone, goes down the line, gets amplified, and before long, it's just a mess of a huge annoying noise filling the room. In most cases, audio feedback is an annoying noise, but not always. the two names that always spring to my mind on it, fairly famous ones, Jimi Hendrix and Tom Morello, because they did it exceptionally well. For them, feedback was just another note that their guitar played. They learned how to control that feedback. And then it was just another note that came out of their instrument. A lot of it is fairly common, but those two did it exceptionally well. And that controlling the feedback gives us a way to reiterate structures. I'm going to erase this picture because, well, by the time I got to the end of that little description, that was just scribbles on the board. It's supposed to represent audio feedback, but I think everybody's familiar with that sound. When we control this feedback, I was trying to avoid the word loop. When we control the feedback to reiterate things, it's called recursion. And I often make that note about efficiency and speed. They're usually very related. So obviously, if we do what's natural to the machine instead of something piled on top afterwards to make our job easier, what's natural to the machine is going to be faster and more efficient. So that's why we want to at least consider this. So feedback, just make sure the definition's clear here, is output becomes input. So technically it should have this word in it. The output feeds back into the input. So then we just get that loop. I guess with our standard flowchart symbols, we have some input, some sort of processing, goes over to the output, but then the output goes right back into the input, and we get a feedback loop. So we have some criteria if we want to control this feedback. Our problem has to meet certain criteria. In order to use recursion, we have to have certain criteria met. So first, the problem has to be reducible. It has to break down into smaller problems, but it has to do it in a very particular way. It has to break down into a smaller version of itself. So the problem must reduce to smaller versions of itself. That will probably make more sense when we look at the first example of it and see that what it looks like when a problem reduces to a smaller version of itself. The second one is the problem must eventually reduce to a base case. So it has to go down smaller and smaller versions of itself, but that can't go on forever. Eventually, there has to be that base case. So must reduce to a base case. A simplest case, that final endpoint. You may see a third item on this list that a function has to call itself, it has to refer back to itself. That's the feedback part. I'll go ahead and put that. I'll use the term we're using in class today. Our function must refer to itself. So that's why I drew the little flow chart up here. The output has to go back to its own input. Otherwise, it's not a feedback loop. So the input leads to an output, and that output has to go back to the input that led to that output in order to be a feedback loop. And that's our criteria to do things with recursion. And part of the reason it's so hard, because some problems naturally do this. The example we're getting ready to look at is just, it's naturally set up for this. But other problems, it might be a little tricky because the problem can't be put into an algorithm that fits these criteria. And instead of adjusting our algorithm, we have to adjust our problem until we can make an algorithm that solves it. And then do some adjustments afterwards to turn that solution back into the solution to the original problem that's going to do recursively. That gets to be difficult at times. That's why loops are included in most programming language, because they're much easier to work with. But for a quick example on this, just, you know, this is just something important for knowing our program, knowing how to work with recursion. So I'm going to quickly cover it. That way you'll have seen it somewhere. So for a quick example, let's take factorials, because factorials naturally meet this criteria. Has everybody heard of factorials? Have you seen those in math classes before? That's your math app.
Yeah, we had a Python question on it.
Yeah, it's the math operation that we use the exclamation mark. So like 5 factorial, that's the number that means 5 times 4 times 3 times 2 times 1. And obviously times 1 doesn't do anything at the end. It just doesn't make any sense to stop that pattern at 2. Right? We walk down, if we're walking down our numbers, we walk down to 1 or we walk down to 0. It doesn't make as much sense to stop at 2. So we just write the times 1 at the end to avoid changing that. It's a math operation that some people see it when they're learning multiplication for like small numbers like this, 5 times 4, you know, just small numbers that we can multiply together. So what is that, like 4th, maybe 5th grade, you might see a quick preview of it, but then it doesn't show back up till calculus 2. So people who haven't had a Calc 2 class probably haven't seen factorials. But so, a unitary operation takes in one number and it's just multiply all the numbers that lead up to that. So generically what it looks like in factorial, that's the number when we take n times n minus 1 times n minus 2, ... and eventually n minus n plus 1, which is a messy way to write that. But if you think about it, that first part's just 0. N minus n, 0. But we need our generic formula to have n's in it, so we have to do that all the way to keep subtracting from our original number until we get down to 0, but we're going to stop at 1, not at 0. And this naturally fits this. The problem must reduce to a smaller version of itself. For example, let's take 7 factorial. Well, we're going to multiply that by every number smaller than that. So one way we could think of that is 7 factorial is like saying 7 times 6 factorial. Because 6 factorial is 6 times everything smaller than 6, which would continue down. Because 6 factorial, that's the same as 6 times 5 factorial. And 5 factorial is the same as 5 times 4 factorial. And you can probably see that pattern is going to keep repeating. It's a smaller version of itself. This factorial is solved by thinking about a smaller factorial, which itself is solved by thinking about a smaller factorial, or which is solved by solving a smaller factorial. And we do eventually have a base case, because eventually we'll get down to 1 factorial, which is start at 1 and walk all the way down to 1. So that is just 1. So it reduces to a smaller version of itself, and it eventually reduces to a base case, which we can use. So we can use that to solve all of our other previous ones. That's the basic idea of recursion. I'll just do a quick example here. I'll go ahead and pull up a PHP script and do a quick example with a function so we can see what that looks like. This is a basic idea there, makes sense? We're just using feedback, and we organize things so that we have feedback, and we can use a smaller version of the same problem to solve the big problem. And we just ask for that function repeatedly. So if there's no questions, I'm going to go ahead and share my screen. And I guess I'll create 2 files, one that has the function and one that has the web page that calls it. I'll do this in a new folder, call it recursion. That way I can reuse the name. So I'll call this library.php again. And then we'll have a script in a moment that calls this. So we need a function that finds factorial, and we're going to pass in some number. So we use our criteria here. First thing we have to do is it must reduce to a base case. So our base case on factorial is when we get down to 1. So there's a selection structure. Those are natural over machines because we have the on, off, and selections. All our selections actually build up from that, but we check our base case. So if that number we're taking the factorial of is equal to 1, our base case, and I'm going to go ahead and write or n is equal to 0. I didn't really state that. In the mathematical definition, 0 factorial is 1 as well. So actually, when we get down to the end, this times 1 at the end, following this pattern, is going to be 1 times 0 factorial, but 0 factorial is 1. So there's times 1 at the end in the math definition, which doesn't do anything because multiplying by 1 doesn't change our number. But if that's what it is, then we're going to return that number, return 1. Because 1 and 0 both have a factorial. 1 factorial is 1, 0 factorial is 1. 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 1 factorial is 1, 0 factorial is So either one of those are our base case. But if it's not, if it's not one, stop the screen share, go back to the point at the board, then we're doing this. Like if we pass in a 7, that's not a 1. So what we want to do is do 7 times 6 factorial. Take care of this. The problem reduces to a smaller version of itself. We'll take 7. If we're not at 1, so like 7, we can take that number and multiply it by the next factorial down. So in our code, that's just going to look like something. If it's not that, then what we want to do is return that number we have multiplied by factorial of the next number down in -1. That line makes sense. And there's our third criteria. The function refers to itself. So the output, this return statement, goes right back to the input. And it keeps going like that. And then that's enough to do that. So now we just need to call this function. Does that make sense to everybody? I guess I could call it right here instead of doing another one. Whoops. I think I can call it right here. If I just echo factorial of 7, it should bring that number back to a page when I load this. So like in this first case, I pass in a 7 in 7, which is not a 1 or a 0. So it jumps to the else. And then it's going to take 7 and then call factorial with 7 minus 1, which is factorial of 6. Which itself, 6 is not a 1 or a 0. So it's going to go to the else and take 6 times the factorial of 6 minus 1, or factorial of 5. And then instead of a loop that just has a counter or some index to keep track, numerical index going through there, the function just calls itself over and over and over again. So I'm going to go over here. And I hope I didn't get a typo in there. I was talking the whole time I was saying that. Okay, yeah. So 7 factorial is 5040. I have a few small ones memorized. So obviously 1 factorial is 1. 2 factorial is 2 times 1 is 2. 3 factorial is 3 times 2 is 6. 4 factorial, it's always times the previous one. So 4 factorial is 4 times 6, 24. 5 factorial is 5 times 24, so 120.
120, and then 720.
Yep, and then 5040. And they get big really, really quickly. If we pass in 10, just go from 4 to 7, we go from 24 to 5040. If we go up 3 more numbers from 7 to 10, we're up in the 3 millions, 3.6 million. Like up to the point we don't even read all the digits anymore. We read off a couple digits and throw in a word. If we go up 3 more, go up 13. 1, 2, 3, 4, 5. We're up in the billions. So factorials grow very, very big, very, very quickly. But this is a faster way to do it because it's natural to the machine. This is what the machine does naturally. And the other reason I always like to talk about this when we can squeeze in the 15, 20 minutes is because we've seen the word stack quite a few times, right? I drew 2 stack heap diagrams on the board today, maybe a third one. I drew at least 2 stack heap diagrams on the board. And that's not the first time I've drawn the stack heap diagrams and talked about stacks, because this is a great example of a stack. So I'm going to put that on the board. So we always use that standard plate reference. Okay, if I erase this part over here, this is, just the general idea of it. Most of it's over there. And this is a better, more precise version of what a stack is in a computer. Not that analogy with plates, though the analogy with plates is what you're going to think about most often. So I'll put in that one that I typed in at first, the 7 factorial. We just have a few layers to type in. So we're going to ask the computer, what is 7 factorial? I'm going to write it like a function. Is it okay if I abbreviate here on the board? If I write F7, well, I'll write fact. That's a short word. So fact, we're going to ask what the factorial of 7 is, which we saw the computer is going to solve that by taking 7 times whatever 6 factorial is. Well, then the computer needs to know what 6 factorial is. So it throws another one on the stack and asks for the factorial of 6. Then, well, we find that by 6 times 5 factorial. I should write bigger because y'all probably can't see that. So here, the bottom layer of the stack, I'm going to ask for factorial of 7, which we find by taking 7 times the factorial of 6. Hopefully that's a little bit easier to see. Well, we don't know what that is, so we're going to ask the computer for the factorial of 6. We know what it is. The computer doesn't know what it is, I guess. I should say it that way. And the computer is going to find that by taking 6 times the factorial of 5. So that pattern continues. The factorial of 5 means the computer is going to do 5 times factorial of 1. And notice how those things just keep getting stacked up. I'm going to run out of room, so I'm going to abbreviate. Then we do the 4, the 3, a 2, and then on the last one, that's where we're asking for factorial of 1. But the computer does know what factorial of 1 is, so it doesn't have to do this recursive call. It doesn't have to ask for another function. It finally hit a return value. In that if-else statement, we're passing in a 1, which means we know what that is. That's a 1. And they were a return statement. So then that 1 gets returned down here to the thing that asked for it. And we're done with that last function. So we pop that off the stack. Then feed that back into what was wrote there. I'll describe it more when I get back down to where I was out of room. And 1 times 2 factorial gives us a 2, so then we'll return that. And we're finished there, so we pop that off the stack. 2 times 3 factorial gives us a 6, so we return a 6. Pop that off the stack. 6 times 4 factorial Well, I kind of ran out of room writing there. Will give us 24. So we return a 24 here. And we're finished with this. We wipe it off the screen, and then we can take 5. And this call is now, we now know is 24. Gives us 120. So we'll return that. And we're done with this. And that's a more precise non-analogy, non-reference. That's exactly what a stack is doing. All those pictures I keep drawing. It's probably more useful to think of the plate analogy because that's something that shows up in daily life. But we want to see the exact thing at least once. So here, well, we now know that this isn't a call to another function. We now know that's 120. Whoops, 120, and we can take 6 times 120, be 720. Whoops, 720, and then we're done with this call on the stack. Hence the name call stack. Yeah. Saying stack is an abbreviation for call stack in most cases. And now this call has been replaced by the number 720, and we can do that math. 7 times 720 gives us 5,040. So that is the more exact picture of how a stack works. We just keep piling up those function calls. It's a call stack, so in order to solve this one, we have to call another function. So we call that, then we call that, then we call that. And that's why the last function that gets called is the first one to run because, well, like we saw here, we had to go all the way to the base case before we could do anything except call other functions. So a more exact version of what happens in the stack and just a quick pass at recursion, the basic idea of it. And recursion is what machines do naturally, so it will always be, it will be faster and more efficient. It's what machines do naturally, not humans. It's difficult for humans. I've been told on numerous occasions that I seem to have a knack for doing recursion, but it does not feel like it when I'm putting it together. It is very difficult thinking at times and frustrating because, like I said, it doesn't involve adjusting your algorithm. It involves adjusting your problem until you can find something that you can develop an algorithm for. So it can be a little tricky. Loops are a whole lot easier to work with. That's why we have loops in most programming languages, but we don't always have it. Anybody have any questions about that? So give that a try. When you have something that you think would fit those 3 criteria, try to do it just periodically, as time allows, because it does take some trial and error and getting used to, and it's a hard way to think. But if you have something that you're looking at it, putting your algorithm together, if these criteria, really the first 2, if it can reduce to a smaller version of itself, is solving this problem basically just is our problem a bigger version of the same problem? We just keep making it smaller, like the factorial thing here? And is there a stopping point? Will it eventually hit a stopping point? If so, give recursion a try. Put together a function that does it, and then just have that function call itself. It's an important thing to know when programming, because sometimes we don't have loops and have to do recursion. But in PHP, we have loops. So for this class, we can use loops. It's much, much easier to work with. I just wanted to make sure and cover it. And it also makes the exact version of a stack instead of the analogy. So when we put algorithms together, it's probably better to think about the analogy and the thing that shows up in daily life. But if any other questions? If not, I guess that will be about it for today. I was hoping to get to strings, but we'll do strings on Tuesday. So any homework that involves strings can probably be pushed back. Expect that, yeah, there'll be more than if we're covering that on Tuesday, that would have been the due date on any homework, any of the string homework. So go ahead and assume that'll be pushed back a day or so. But then the stuff after that is objects and exception handling, which will go fairly quickly. So we should definitely be back on what the schedule says next week. And then the big thing this week is the project proposal. So make sure you get that together and think through what you want to do for the project. Get that to me. There are several people that on the previous the previous assignment, instead of a grade, you got an email saying, okay, like, line 72 has this, line 34 has this, and very detailed instructions of what you would need to do in order to get the full points. So until we run out of time at the end of the semester, that you'll often get that. So those that got that email, please get those adjustments made in there. If there was anything that I tried to separate the list. So if there was stuff that definitely needs fixed, it's still going to apply on the module 2 when I tried to separate that from the list that would just be a couple points here and there. But if you got the email instead of the grade, please get those fixed and submitted to me. And it always goes with the original submission date. So it does not, if I ask for a resubmission, it does not count late. Technically, I guess from the policy, technically, if your original one was turned in late, it would still count as late, but then I'd have to do a bunch of math when I made those adjustments afterwards. So it'll go back to if I ask for a resubmission, it goes to it doesn't count as late. Let's just say that, because I'm probably not going to sit there and redo the math to figure out what the late penalty was supposed to be for the first submission or whatever. And resubmissions, I'll just pull the late penalty off there. But otherwise, that homework that was supposed to be due this past Tuesday, which includes up through arrays, is going to be due tomorrow. I think I already have several of them in there. I haven't started grading those yet. So please get those in by tomorrow and get that first one going. And our homework is going to continue on that same pattern all week. So a couple things on my list here we'll do next Tuesday. And otherwise, that will be about it for today, which leaves us an hour of lab time. As normal, I will keep my video set up here. Ivy Learn messages and text messages make noise on my phone. So
I'll make noise now because I need a little JavaScript tutoring on something, because quite honestly, if I don't get that straightened out, this other stuff is never going to happen because I'll be too blown up my brain. So if you get a minute, I think I know where the problem is. I just don't know quite how to fix it because the syntax is muddy.
We can look at it. Should probably address PHP questions first. So that was it for class. If anybody has some questions, I'll be here for the next hour, or you can just stick around now. And I will see you all on Tuesday, or let me know if you run into any problems. And with those programming assignments, I'm not trying to trick you with them. I have practice versions, so give it a try. But if you get stuck, get a hold of me and we'll go through my practice version and talk about the algorithm and get you on track that way and stuff. So I will see you all next week. Have a good weekend.
Okay.